the show. I've got the camera view now. This is also a good opportunity for a sound check.
How do you want to do a sound check? Oh, you can.
No, I mean, just me.
Tap anything or sound check 1, 2. No.
Yeah.
Make me feel more like a rock star or something.
All right. Use my mic here.
So there are like. Yeah, like all this stuff is like this imagery is
Ready to pair.
all right, well, forget that.
Oh, I forgot. That should work. Oh, did you have? Yeah.
What's that?
Yeah, go put it over. There you go.
Oh, okay.
Yeah, just accept it. You don't have to do anything. Yeah, just hit close panel.
Oh, okay.
There you go. So now try left and right. There you go.
Perfect. All right. Thank you.
Yeah.
This yours?
Yes.
I mean, you're like fully prepared for this.
I give a lot of presentations.
Said you're a professor?
No, I give a lot of presentations.
Oh, okay. I thought you said you had students. Is that for training? All right. I think we're going to go ahead and get started. Blaine seems well situated with his giant bug, so that means that everybody else is ready to go as well. Thanks, everybody, for coming to the first Nova Kubernetes meetup in Northern Virginia. I appreciate you coming out.
Want that off?
Sure. This obviously, so first off, thank you to everybody for coming. This doesn't happen without you showing up. It's just me talking to empty space or my coworkers, which they're probably tired of hearing me anyway. Yeah, there you go. So for sure. So, but thank you for coming out. Obviously, it's a testament to everybody being very interested in this technology. I know it's super hot right now, like Hansel. So I'm glad you made it out. Yeah, there you go. Somebody got that, and one person got the right ones. Great.
You got to give us blue steel later?
Yeah, I'm going to stop with the references because obviously the movie references aren't working. Also, thank you to I thank my company for hosting us, providing food and drink and all that stuff. You know, it's kind of easy for us to do this because we're way into this technology. We're way into technology in general. Hopefully, like our meetup space, we're hiring. So talk to me afterwards if you're interested in a job. That's the only pitch I'm going to give. But thank Otimo for the space. I'm just going to talk real quick, give a real quick intro, and then get into the presentations because I don't have a lot of pontificating to do. But this is only way this is going to continue, this meetup, and I'm happy to host. I'm happy to organize. I'm happy to find places to meet and talk to people for presenting. But it only works if people in this room and people online decide that they want to share what they're doing with Kubernetes. It's really the only way that it's going to work. I'm happy if you reach out and say, hey, I'm interested in presenting with the topic. I'll work with you on figuring out what's good and what will work for the meetup. I'm going to try and continue with the 2 presenters once a month to see if we can get that kind of momentum. I know that's kind of what DevOps DC has. I'm not saying we're going to get as big as that, but that's a goal to aspire to because they have a very good turnout and they constantly have really great presentations and great presenters. So ways you can help, one is just by doing what you did tonight. Showing up. That's the easiest way to come out. You come out and learn. You come out and support us, the presenters. And if any of you're presenting, I will show up for you as well because I'm interested in hearing what everybody is doing with this technology. Hopefully everybody here is super into this and is excited about using it as I am. 2, volunteering to speak. I just mentioned that, but there are a variety of ways to contact me. I'll mention that at the end of these slides, ways to get in touch with me. Meetup page is probably the easiest. But it can be about anything. It can be about culture change that you help implement to get Kubernetes to work in your company, Kubernetes failures. I know nobody seems to want to talk about their failures, but you can learn just as much from having a bad implementation as you can from having a successful one. So there's no real bad presentations. It's just about sharing. As you can see, we don't have a huge group here. Like this is probably 40 to 50 people, which is awesome for a first meetup, but it also shouldn't be that intimidating, like especially if you want to maybe prepare a talk for a conference or something like that. This is a great testing ground. And I'm happy to have as many people who want to do that as possible come talk about their presentations and try a trial run, get feedback, that kind of stuff. Another one is to volunteer to host or provide food or whatever you can do to kind of sponsor the meetup. You know, like we're happy to sponsor it, you know, as often as we can, but it's nice to move around and get into other people's venues. You know, it's good for you to have people in your place and see, you know, what your place of work looks like if you're interested in doing that, if you're proud of the place you work, I hope you are. And have people in there and sponsor food and drink and all those kind of things and host a meetup. And the last thing you can do is suggest topics. So I sent out a survey. Hopefully everybody got it. I can also post it to the, should have posted it to the topic board. But if you had a chance to fill out the survey, the purpose of that was to kind of gauge what people are interested in hearing, your level of experience with Kubernetes, and where you want to meet. And got a lot of feedback that Reston, Tyson's Corner area is a great place for everybody to meet, which I guess was kind of surprising because I always think of people being in DC or Arlington, kind of located, but maybe you work there and you come back here on your way home, or this is more convenient. So I'm glad to hear that this is a convenient spot, and we'll try and keep it in Reston, Tyson's Corner area. We may move to Arlington or Alexandria every once in a while, but we'll try and keep it focused around here. But also suggest topics. Like I got a lot of feedback. I mean, there's a million topics everybody wants to hear about. I mean, every topic you can think of around Kubernetes was suggested in only, I think, about 33, 34 responses. So there's a lot of things that people want to learn. So if you're doing something with Kubernetes and you think, probably everybody's doing that, that's not true, okay? We have a group, I think, between 1 and 5 of experience level. I think the average was 1.7, something like that. So if that gives you an idea, most people are just learning or just getting up to speed or trying to figure out what it is and how to take advantage of it. So don't think that the topic that you have to present is too, you know, not advanced enough or something like that. It's part of the reason I'm going to be presenting on, you know, KOPS on AWS. I'm not going to be showing rocket science up here. Like, it's just going to be a starter thing to help people learn and get started if they haven't used it before. Those topics are great, and we can always do like a beginner and advanced topic or an intermediate and advanced, try and mix it up. But there's no bad topic. So just shoot me an email and let me know if you're interested in speaking. Anybody want to volunteer? No? There we go. All right. There's always one. There's always one.
Speak.
Yeah, you're ready to speak. You can speak tonight if you want.
That'd be awesome.
All right, great. So I also run DC continuous delivery. I don't know if anybody here has attended DC. A few of you have attended DC continuous delivery. I see some familiar faces. So this slide should look super familiar. But one thing I like to do is, in a community like this, there's hopefully always people looking for new opportunities, and there's no lack of people trying to hire talented coworkers. So always have an opportunity, and I'm going to add to this the way that DevOps DC does, and add also announcements to this as well. So if you want to announce a meetup or conference or something like that, you can do that as well. But if you're hiring people or if you're looking for a job, please feel free to just raise your hand and talk about that opportunity and let everybody know. Yeah, go for it.
I work for a company called Upskill. We are a startup, but we are seriously funded startup. We work a lot on Go and Kubernetes. So if somebody's still looking for Go, Kubernetes, microservices, we are pushing the edge. So it's upskill.io. So if you guys are looking for a job, we're doing a lot of fun work. Just like so we are hiring.
Awesome, thanks. Anybody else? Don't be shy. No one wants new coworkers. You like everybody you work with already. All right, we're hiring at Otimo. I'll just take this opportunity. I mentioned that already. We do infrastructure automation, containers, continuous delivery, and cloud. So we help companies automate so that they can innovate. That's pretty much our bread and butter. We also do cutting edge. We're also on the edge. We're on the edge too, just so you know. So we're both competing on the edge. We'll see you there. But if you're looking for a new opportunity, just come talk to me afterwards. I'd be happy to talk to you. Lots of fun stuff in the pipeline. Excited to work on, especially if you're at this meetup in HIT. Any announcements, meetups, anything anybody wants to announce? No? Everybody's super quiet. Just like really anticipating this awesome presentation. I really got to knock it out of the park. So there's no upcoming meetups yet because I need volunteers, as I mentioned. So I'm already lining up some potential venues. I've had some people contact me about bringing the group there, which is awesome. Like I said, this only works when people help me out, but I need speakers. And the way I've tried to work it is to have at least a 3 to 4 month backlog. So that might mean you come up sooner rather than later, but it's first in, first out. So the first people to contact me is usually the people I have present. Like, I'm not going to pick favorites. Like, if you want to present, you're the next one up. I think I have one presentation identified for next month, so I need another one. So, but if that's too soon, you're more than welcome to say, I don't want to present next month. Like, that's way too soon. I want to do it in October or November or whenever you want. Like, I'll pencil you in, and that's not like a 100% commitment until we get about a month or two out, and then yes, then I need you to actually show up. But prior to that, just an idea, and yes, I would like to speak at this time, or even if you don't have an idea and you say, look, I just want to force myself to present. I've done that before. That's how I got started doing these type of presentations. I said, I don't know what I want to present on. I want to do a topic at your meetup, and I'll present in January. And you just sign up. So yeah.
We open a meetup. We hold with presenters. So essentially, people can hold a present. People can see what each others are doing it. I saw this in one of the another meetups. So just throwing that as a suggestion.
Awesome. That'd be great. Yeah, you can do that. Definitely. These are all the ways to contact me that I mentioned. So the first two are Twitter. The next one down is my email address. Please don't give it to any spammers. That's actually my real personal email address, so don't mess with me. And then the last way, like I said, the easiest way is probably through the meetup page, which you found obviously because you're here. There's a contact organizer. By the way, our other co-organizer is sitting down. I don't know if he didn't want to be identified, but this is Joe Thompson. He's my coworker. He is also the co-organizer who I'm going to start to transition everything to eventually. He just doesn't know it yet, but he will get that. Any questions about any of this? Concerns? This meetup sucks already. You can leave now if you want. I'm not going to hold it against you. All right, cool. Well, then I'm going to jump into the first presentation. Once again, thanks everybody for coming. Really appreciate it. And let's get started. All right, please welcome me. I'm not going to make you clap, but you can if you want. All right. Come on. All right. So, KOPS. Who's heard of KOPS? Awesome. That's good. I'm actually glad it was less people than I expected, because it's never fun to give a presentation. Everybody raised their hand, and then like, we're going to tell you how you don't know what you're talking about. So now only some of you will know that I don't know what I'm talking about. All right. So KOPS. So my first generic intro slide, I realized that I also didn't introduce myself at the beginning. My name is Sam Brown. I work here at Otimo. I like solving hard problems with technology, and probably like most of you, I have shiny object syndrome. Can anybody relate? Yeah, like what's the newest technology of the day? I got to jump on that. Serverless is next, just so you know, right? It's going to take over the world. But that's kind of how I find my way in technology and how I've kind of stayed relevant, is that I really do have shiny object syndrome, but it's in parentheses, it's controlled, right? Like I do try and figure out why technology is relevant before I adopt it and make sure that it's something that's going to stick. Somehow I missed OpenStack. Darn it.
You didn't miss much.
No? Brutal. All right, fair enough. Yeah.
I missed a lot.
Oh. There you go. I'm the containers and continuous delivery practice lead here at Otimo, which means I help drive that business here. I'm trying to build those practices and find lots of clients that need help in containers and continuous delivery, and obviously we're focused a lot on Kubernetes. I'm also the organizer of DC Continuous Delivery. It's not defunct. It really will have more meetups, hopefully next month. Just kind of took the summer off, but if you're also interested in continuous delivery, please find us on the meetup page. And I'm a recovering Java developer. So I don't know if any of you can relate. I did Java for many, many many years. It was both a good and a bad thing, I think, but it's helped me get here, so I guess it can't be all bad, right? All right, so installing Kubernetes. On Google and Azure, you don't have to, really, which is kind of nice. It's a great place to start. It's where I started. It's awesome. In Google, they have GKE, Google Container Engine. It's kind of a pre-made cluster for you. You can pick all the options you want, have it start up, and pretty much be in business in about 5 minutes. I definitely recommend it. It's really cool, and it's a great place to start. Azure Container Service, I've not used as much, but it's based on Kubernetes, and I think it's getting closer to upstream Kubernetes. I'm not going to pretend like I know a whole lot about it, but they're moving in that direction. And then AWS is potentially coming soon. That's why I have the troll there. I don't know if you saw the bottom. AWS recently joined the Cloud Native Computing Foundation, which is the umbrella under which Kubernetes lives, with Linkerd and Prometheus and a bunch of other open source projects that they're bringing together as cloud native technologies. To me, that indicates the writing is on the wall that AWS eventually will probably have a Kubernetes offering, but at current they don't. So that's kind of how we get to here. Why do we need KOPS? So why do we need an installer for Kubernetes? Because this is Kubernetes and it's super complicated. Anybody who's looked into the architecture for more than 5 minutes is like, wow, there's a lot going on here. And it's all useful and it's all purposeful, and you don't have to know all of the internals inside and out to run a cluster, but this is just kind of what it looks like at a small scale with only 2 worker nodes. Imagine it scaling out. You've got to scale all the pieces and you've got to keep everything up to date. It can get pretty hard to manage pretty fast. So if you're not going on Google and you're not going Azure because you're an AWS shop, which, who's AWS here? Who's doing AWS? All right, a lot of people. Cloud Native Computing Foundation ran a survey and they said that 63% of people are running Kubernetes on AWS without a native platform, right? So that tells you anything. There's a lot of shops who are running AWS that want to run Kubernetes as well. And being that they don't support it yet, that's where we find ourselves with KOPS, right? So KOPS is the Kubernetes Operations Tool. That was its short name. It's actually part of the Kubernetes project, but they wanted to give a cohesive way to install Kubernetes on AWS that people could rely on. I know that kubeadm has come along also, but for now, KOPS is kind of the de facto way to install it on AWS. It's a pretty comprehensive tool, as I'll talk about a lot of the options, but they also bill it as production grade, installation, upgrades, and management, once again, on AWS. They have alpha support for Google Compute. So if you did want, if you're kind of a masochist and for some reason you didn't want to use GKE and you wanted to just put it directly on Google Compute, you could do that if you really wanted to. I'm not sure why you would, but maybe you have a use case that I don't know about. So it does support it in alpha, and I think they lightly support VMware if you want to do an on-premise installation. I haven't tested either of those, but I can tell you that I've had great success with KOPS on AWS, which I'm going to talk about. Oh, by the way, if you have questions or anything like that, this can be completely interactive. And I'm not going to talk at you. I will ask questions at the end, but if you have a question, stop me in the middle, and I'd be happy to answer questions. So key features, it's a CLI that can create and manage cluster state. I mean, that's what it is at its core. So if you want to create a cluster in AWS, you would use KOPS to do that. You can do it with a new or existing virtual private cloud, which is pretty cool. So it can create a cloud for you, virtual private cloud for you, or you can attach to an existing one, which is nice because some people don't just have the freedom to create VPCs at will. If you have one and you want to drop a cluster into it, you can indicate that on the command line. You can do it public or private. People get worried that all of a sudden you're going to stand up a Kubernetes cluster and expose it to the world. You don't have to do it that way. It also, and yeah, I mentioned Bastion servers as well. How many people are familiar with a Bastion, what a Bastion server is? So a Bastion server is kind of a jump box to get into another set of computers. So if you have a private cluster, you can set up a Bastion server, you SSH into that, and that server has access to the rest of the cluster. So if you want to get super secure, you basically want this in no way near the public internet. That's supported by this tool, and I know that's important to a lot of people. It has high availability Kubernetes master. This has been something that's traditionally somewhat hard to set up, but it's literally a command line option that I'll show you. That's high availability across availability zones in one region within AWS. So you specify the availability zones across which you want masters, and now all of a sudden you have HA masters. So if an availability zone was to go down in AWS, you still have other ones, and you have connection to your API server. And just a little background, I'm not going to go into kind of the Kubernetes architecture in depth or anything like that, but just high level, you've got an API server, which is your master. All commands to Kubernetes go through that server. So if you were to lose that server, you lose communication with your cluster, which is obviously a very bad thing. And that's why high availability is super attractive, because it's going to auto-register with a DNS address, so you can always get to your cluster when you need to. So like I said, if an availability zone goes down, you still have access to your cluster, which is pretty cool. And it's literally a command line option. Yeah.
So in the ACs, we're actually auto-identify which ACs in that region, or do you have to specify which ACs you want in that region?
You have to specify the ACs in command line.
Can you repeat the question?
Yeah, the question was, how do you will it automatically detect which availability zones are available in a region? And it doesn't do that. Now you have to specify them on the command line. Yep.
There is an out-of-the-box configuration of you set it up with a new VPC, it'll create a subnet for you the availability. You don't necessarily have to specify. Let KOPS do it all itself.
But how did you finish on your USBs 1A, 1B, 1C? Yo, there are 6 availability zones. So you say, okay, which availability zones, or it's going to take all the 6?
You define it.
Yeah, right, that's what I'm saying. You're going to define them as how many availability zones you want. One caveat in that,
Yep.
you don't pick 2 because of the core, like you don't pick 2 availability zones, because people who know it's based on graph technology and SCD, you can either have 1, 3, or 5.
Yep.
Having 2 is not possible.
Does everybody understand that? Yeah.
Does it tolerate multiple regions, or is it just multi-ACs?
Just multi-ACs. Yeah, single region. Yep.
One thing I've gotten interested in lately is using Spot Market for that, because when I've been using the Spot, it's been 1/8 of the cost of the instances, and I've been able to keep them going for days at the time. So I've been particularly interested in whether or not having worker nodes be Spot instances one thing is, does KOPS inherently support Spot Market, and secondly, what kind of?
I think that it does. I think I found it. I haven't used it, but I think there's an option that I saw in the command line in the cluster create, to where you can say the type of instance, not like the size, but like you could do like the market instance type, and I think you can. I think that was something that they had. Rolling upgrades in the cluster is something you can do through the tool, which is pretty awesome. So if you want to upgrade the version of Kubernetes, it does a rolling upgrade. It will stand up a new version of one of the servers and take down one of the old ones after that one's available. So upgrading your cluster becomes pretty easy. I'll actually show you that in the demo that I'm going to do. But that's been traditionally a pretty hard thing to do as well. It also can do rolling upgrades across scaling the cluster out as well. And I'll show you scaling up the cluster too. And lastly, but definitely not least, is the configuration management is supported. Some of you may be thinking, and like I did when I first saw this, is having a command line tool is great, right? Like I like having a command line tool to do things, but that's not always, how does that go through version control? The answer is it doesn't, right? Like how do I interact with the cluster in a way that is checked and that goes through my team's process? And the answer is that KOPS supports both CloudFormation and Terraform. So if you're not familiar, you can read CloudFormation is the native scripting tool for standing up AWS resources. Terraform is from HashiCorp, the makers of Vagrant, is a similar tool to CloudFormation. Works with a bunch of different clouds, but also with AWS. And what you would do is when you do KOPS and you send in a command, you do a -out, and you can say either CloudFormation or Terraform. It will output a script for you, which you can then check into version control and then run that tool. So I know it seems like a two-step process, but because KOPS knows Kubernetes so well, and there's not as much native support in CloudFormation or Terraform for Kubernetes, that would be the methodology that you would take. But then you can run that through your team, right? You can also run plan checks, which Terraform and I believe CloudFormation now supports, where you can check, what are you going to do before I have you do it? Show it to me, and then if that all looks good, then I will execute it. If I don't like it, then I won't execute it, and I can fix it prior to running it. So it's declarative state management, if you're familiar with that. Questions? Yep.
Is it an all or nothing, or can you manage individual cluster components? So I have existing clusters, and this would be interesting to look at. But I just spin up for API servers?
So you can do groups of servers and types. I don't think you can just spin up masters alone. And the reason you can't hook into existing resources is because KOPS is going to manage the state for you. And that's part of the reason you have to use the tool. With the other two tools, with one of the other two tools, is that now both tools are managing state, and it's trying to understand what your cluster looks like. I'm going to show you, it stores its state, KOPS stores its state in S3. So it wouldn't be able to know what state your cluster is in prior to starting it, so it can't go and evaluate what you've got, unfortunately. Does that kind of answer your question?
Sure.
Okay. Sure, but not really.
It does.
Okay, all right. If not, I'm happy to keep going.
There are ways you can probably work around this.
Okay.
Fair enough. Like,
Yep. There are ways that you can pull state into Terraform, I know. I'm not sure about CloudFormation because I haven't used it as much, but I don't know how you would then integrate that with KOPS. So
I guess my concern would be, I wouldn't want to use my S3 cluster, but if this thing started controlling my API servers, those can go away for an infinite amount of time.
Right.
And the cluster state doesn't change.
yep,
Yeah.
fair enough.
You must put it back into putting that back into the KOPS format. The state that's making that.
Yeah, I just have to start.
Yeah, right, you're right. Or you can manually do that.
All right, everybody cool with this? All right, awesome. So getting started, there's a lot on this slide, and part of it got a little cut off, but I'll post a link to these slides. They'll be public. So the first thing you want to do is you are going to need kube control. If you're not familiar, that's the command line tool to interface with Kubernetes. I posted a link here on how to install it. It's fairly straightforward, but that's how you issue commands to Kubernetes from the command line. KOPS makes use of this installation on your machine, so because kube control controls the security by which you talk to Kubernetes, and it's also going to be issuing commands to the cluster as well. So KOPS uses kube control, so you need that installed, and it doesn't look out for you and install it on your behalf, which is I kind of like, because you might have been using it for other things. So you need to install kube control, then you can install KOPS. This was copied directly from their GitHub page, so I've not actually tried this recently, but this should work. So you can install it on OS X or Linux. If Windows, you probably need to stand up a container or a VM and run it from that. But that's how you install KOPS. Next, you're going to want to create an AWS account. Everybody created an AWS account before? It's fairly straightforward. No? I know you haven't. It's fairly straightforward to go start up an AWS account, but you also need to install the AWS CLI so that you can have profiles locally that KOPS will use. And a profile is just a collection of your key pairs, or not your SSH key pairs, but your secret key for AWS and your access key, so that it can do actions on your behalf against AWS. I mentioned this before, you need to create an S3 bucket, and that will hold your state from KOPS. So when it's done, it's going to send up to S3 the way that your cluster looks, so that it can reason about how your cluster is if you make a change and what kind of diff it needs to do to update the cluster to the state that you desire. So it always needs to know what it looks like, stores that in S3. And then optionally, which I would probably recommend for everybody, because it's not that hard to do, and so you probably should, is to create a user in your AWS account with specific IAM roles. And IAM roles are what gives an account access to specific parts of AWS, right? And so KOPS is going to be doing things on your behalf with your account. If you give it admin, you're pretty much giving it rights to do anything. And if you share KOPS or other people are using KOPS, you might want to give them the same account so that they don't have rights to go do crazy stuff in your account, create and destroy things, whatever. You just want them to be able to control the cluster. So there's roles listed, and this is on GitHub for KOPS as well. The roles that you need to have, and like I said, they'll be listed out. But if you create that user and then that is the profile that you pass to KOPS, then that's what it will use, and then it won't be able to do anything else against your cluster, which is probably pretty nice. And your security people will love you just because you created an extra person. Questions on any of that? So now we're ready for KOPS. All right, so I'm going to do this in just a second, but I'll explain a little bit about what's up here. So this is pretty simple. This is creating a Kubernetes cluster, which is pretty awesome, which is why I love this tool. It's been great. So this is actually a bash script that we run to create clusters. The first thing you'll see that I export my profile that I mentioned that I just created. That's stored when you use the AWS command line tool. You can save profiles, which is just a short form name for your credentials. I highly recommend it, so you're not always putting your credentials in and crazy stuff like that. It's easy to reference. Then you want to say where your KOPS state store is. So it's just an S3 location. It's an S3 bucket. Where is it going to put the state? You have to pre-create this. If you don't, KOPS is going to complain and tell you there's nowhere to put the state. Please go back and do it. And then the next thing is the actual command itself. There are a million options, which I'm going to show you in a second. After I create this, I'll go into some of the other options, but these are just a few. The node count, so how many worker nodes you want. Pretty straightforward. How many zones you want it in. So we're doing, actually, like you said, you can't do it in 2. This is actually a typo. I will have 3 in my command line. So you have to do at least 3 zones, one zone or 3 zones, so that you have a quorum. Those are the zones where it's going to create the worker nodes. Okay. Then you also have master zones. So when I mentioned HA for master servers, this is where it's going to create your master servers across the availability zone so that you get high availability, which is a pretty key feature of being able to contact your server. DNS zone. So there are ways to do this outside of AWS. Like if you're not registered with an AWS zone, there's ways to pipe in a zone from another provider if you've created a DNS zone. The easiest way, obviously, is to do it through AWS because it will work with Route 53 and then start updating all your DNS records, which is really cool. I'll show you that in a second. And so we already have an AWS Route 53 zone on xc.com. And so you can specify that here. Node size, that's pretty obvious if you've used AWS before. It's how big you want your worker nodes to be. T2.large, T2.extra large, T2.extra large, however big you want to make them. How much money you want to spend, pretty much. Master size as well, you get to specify them the same. I would also, just from experience, say don't make your master nodes too small. Surprisingly, your master nodes will end up running a lot of stuff, especially if you're doing any type of monitoring or things like that. You're going to start deploying like daemon sets, which are applications deployed across on every node in the cluster to start doing monitoring, log aggregation, all these type of things. If you make your master nodes too small, I will tell you they will explode. Like they literally just shut down. They'll start getting failures, and you won't know why. And the reason is because you've set a lot of different applications to run on the master nodes. You're thinking, well, it's not going to schedule my apps like the apps we've developed. You're right, because they're not schedulable. But daemon sets are different. Those are things that will run on everything. And so, especially in monitoring, those things take RAM and resources just like everything else, and they have to run on every node. So just be aware. I've had not a lot of luck. I'm going to do a T2 medium because I'm not deploying monitoring or anything like that. T2.large has been pretty much the low bar for masters for me. You might have different experience, your mileage may vary, but when I start to put monitoring on everything, that's the low bar. Yeah, what's up?
Do you run into any issues with CPU credits using the T2 mediums?
Meaning like contention?
Just, with the T2s, you go through all of your CPU credits.
I'm running them a lot as demo clusters. This would be for a demo. Yes, you need to run a more stable image if you're going to be running something like for production workloads and CI/CD and things like that. This is a script from a demo cluster that we run, so we're running it on spots and stuff like that. Yep. Yeah.
Do you know if the Route 53 entries require KOPS number?
I do not know that.
I think so.
What uses it?
I think it might.
Kind of, but
I think it's
you have an
I think it
option
does.
to override that. It works out of the box with Route 53, so it's a lot more easier than all you gotta jump to.
Yeah, it's going to make a lot of entries in there to find everything.
Yes.
I don't know that it is required, but it certainly makes everything easier to find, especially if you're using public. Like there's an option here, I'll talk about it on the next slide, about doing public IPs. So it'll register public IPs in your public domain so that you can get to the API server from where you're at and all that kind of stuff. Kubernetes version, obviously that's an important one. Current version is 1.74, right? No, 1.75 is not out yet, right? All right, awesome. All right, all right. Just wanted to make sure, slide it's not that old. And then at the end, I added the you're going to put a name in there, which I'll show you. I'm just going to put in a name for what you want the cluster to be. And then at the end, you add -- yes for a lot of command and KOPS. You don't always want to do that. So the --yes is basically execute now. For almost every KOPS command there is, if you don't put in --yes, it's just going to do a nod, right? It's going to tell you what it was going to do. And this is where it's awesome to know a plan ahead of time. What am I going to execute before I execute it? You run it without --yes, you find out what it's going to do, you run it, same command again with --yes, and then it will execute your command. So I really like this mode, especially I've used Terraform a lot in the past. I love being able to know what it's going to do before it does it, especially as it relates to production. It's usually a pretty good thing to do. So I've definitely would make use of that. Questions on this? Demo time? All right, show you that I actually can do this, theoretically. All right. But I don't need all that stuff. All right, so I'm going to cheat a little. Yes, I ran this earlier to make sure that it would all work.
Did you zoom in your demo?
Yes, good call. Better? All right. All right, there we go. Change the cluster name. All right, so I'm doing this all on one line, or all in essentially one line, of the same script that I executed before. I'm going to pass in the profile. I'm going to pass in the state store, which is the S3 bucket. Also, your AWS profile needs to be able to access that S3 bucket. Maybe that goes without saying for those who use AWS, but it is something that you could run into. You have to make sure that you actually have access to this S3 bucket from the profile that you're specifying, because it's going to be writing stuff there. I'm going to create 2 nodes. The zones are US East 1A, 1B, and 1C. The master is going to be also in A, B, and C. T2 mediums, Kubernetes version 173, even though the current version is 174, because I'm going to show you rolling upgrades in a minute. And then the name I'm giving it, you want to give it a qualified name with the DNS name that you gave it. So I'm using DNS zone utimo-xc.com. So I'm just adding subdomain onto that as the cluster name. You can go as far out as in the subdomain as you want, but it's usually easy to just go one out. So I'm just going to do novacube.utimo-xc.com. I'm going to do the yes. Oh, how did that happen? All right. I accidentally hit enter before. All right, well, we'll just delete it and then we'll recreate it. Yeah, I don't know, that's weird. There we go. So off it goes. It's going to be doing a whole bunch of stuff, issuing certificates, IAM profiles, registering stuff with Route 53. Let me go into, you don't need to watch all that. It's going to tell you in a second that it's done. Because what it's doing is it's starting. So it's going to take time to stand all this stuff up, but it's getting ready for action. Can everybody see that? Oh, why is it off to the side? Come on. There we go. All right. So what we can do is, I'm using the KOPS CTX tool. If you haven't heard of it before, it allows you to switch context, which is Kubernetes clusters, really fast. It's just kind of like a nice shortcut tool. But you can see that the one that's highlighted is the novacube.utimo-xc.com. So that's the cluster I'm linked to right now. So if I do kube control, get nodes, it should tell me that there's nothing there.
Do you add one cluster? Are you on your terminal?
What's that?
Do you add one cluster? Because I have multiple clusters, so I usually put that in my badge as which cluster I'm on. Basically, I'm on Quad, QA, yeah.
Yeah, I haven't added it to this terminal. I probably should, as like which one I'm in. Yeah.
Brought down QA to that's dead.
Who has done?
Oh, I messed with pronouns.
By the way, it also looks for your key file. I think it looks for ID RSA. If you don't have one.
Getting crushed by the demo guys right now. Oh, okay, that's all right. So what we're doing right now is we're waiting for the cluster to spin up. They do a couple things. How can I exit? So what you can see here is that, make this a little bigger. My cluster's starting to come up. These are all the nodes. We've got masters and workers coming up. So I should have 3 masters and 2 workers. They've all started. They're still initializing, so they're installing a lot of stuff. The initialization, I think last time I did it took around 5-6 minutes. So we'll come back and visit that in a minute. While that is playing through, I'm going to come back here. So I'll talk about some other options on creating the cluster while that's spinning up. So there are like obviously a lot of options. I deleted some options out of this window, if you can believe it. These are the options for the KOPS create cluster and what they do. It's worth looking through this because there are a lot of great options. I'm going to just highlight a few of them. Admin access, so you can restrict API access to a particular CEDR address, which is pretty nice if you want to restrict it to your access so that people cannot get to your cluster. Only you can get to your cluster from a particular IP address or IP range. That's pretty nice. You can associate a public IP address, whether or not to give a public IP to your cluster. Like I said, this can be a big security concern when you're doing this. So if you don't want to, I would actually suggest doing a private cluster, which is a command line option as well. Authorization mode is always allow or RBAC. That's for actual Kubernetes authorization. I think the default is always allow, but RBAC is really well supported in 1.7. So role-based access control, you can use OpenID Connect, you can use LDAP, you can use a variety of ways to give people access to your cluster. So I would recommend turning on RBAC for your cluster. Bastion, we mentioned earlier, cloud labels. If you use labels for your AWS infrastructure to give key value pairs to all of the resources created, this can be pretty important. DNS, we talked about, DNS zone. Encrypting etcd storage. So etcd is a key value pair that holds the state of your Kubernetes cluster. You can have it encrypted, and that's a command line option as well, which I recommend turning on. Master count, how many masters you want, master security groups, master size. All these things are all tunable, tweakable things. You can read through this at another time. I'm not going to bore you with all of these, but these are just some of the options that are on there. I suggest looking through it. I think I heard somebody mention that it uses your SSH, like your RSA key for your SSH into your instances. It uses, I think, ID_RSA by default, so in your .ssh directory. So just be aware that definitely got me the first time I used it, that if you want to SSH into your nodes, that you do have SSH, and if you have a public-private key pair in your .ssh directory, it will use it, and it's just going to use it by default. You can specify it with the SSH public key here, which one you would rather use, but otherwise it's going to use ID_RSA by default. So hopefully you know the password to that, or I don't know if hopefully you don't have passwordless. Nobody has passwordless SSH access, right? No. That should not go over here. Don't any of you guys use SSH? Like, what's going on? Man. VPC we talked about earlier. I think that's about it. Questions on any of this stuff? So,
Networking would be an interesting option in that to talk about.
Oh yeah, networking. Did I have that one on here? Oh yeah, I do have networking. Yeah, so I could go into it. The problem is if you don't, perhaps some people who aren't as familiar with Kubernetes.
I think that would be an interesting option.
Yes, so Kubernetes being an extensible, pluggable model means that there are a lot of places where you can inject custom providers for different features, and networking is a big one. So there are a few open source networking providers that are out there right now. Calico, Weave, got another one at the top of your head you can think of. Flannel, there you go. They all have different options, and you can set network security policy using these tools. And in here, you can specify which one to use out of the box. So it's going to use this on top of, or instead of, Kubernetes native Kubernetes DNS provider, or networking provider. So you can get enhanced networking features installed, by KOPS out of the box. I've not done that a ton because I haven't had a huge need for extensive network policy, but you can provide that as a command line option here. So yeah, that's if you use private, you can't use Kubernetes. Okay. Thanks.
A question. I've only used KOPS a few times now, but I was wondering, is there a way to specify user data for the launch? A chance that you can customize the installation?
If you can do it?
If you can include user data.
Anywhere. And if you edit the manifest,
yeah,
you can edit or copy.
You can specify
you create the cluster, you generate it, and then before you update, you go pull it from S3, edit it, put it back. And, it's kind of an extra step, but it makes sense because then it templates off of that stuff too. It's all baked in.
Awesome. Yeah, I haven't tried that myself, so thanks. Awesome. We waited long enough. I killed enough time. So here's our cluster. 5 nodes ready. Now I can actually run the validate. So what we're going to see is we're just validating, using KOPS to validate that our cluster came up according to its state. So we have 3 masters across 3 subnets, East 1A, 1B, and 1C. We have 2 nodes across those availability zones. Obviously, we only have 2 worker nodes, so they're only going to be in 2 of the 3 zones. And then down here, we've got the actual, here's the nodes, the internal names, the role that they are, whether they're a master or a worker node, and whether or not they're ready, and they're all ready for action. Down here, I'm just running the regular kubectl get nodes, which is to show you what nodes are available in your cluster. Like I said, we're running 1.7.3, and we should have 5, 3 masters and 2 workers, so we're good to go. Kubernetes cluster. How long was that? 5 minutes? 4 minutes? Nobody was timing? Yeah, demo actually worked, right? It's not that.
US worked for you.
There you go. So I ran through this, validating the cluster. One other thing I'll show you real quick, which is nice, is we can also validate it via the dashboard. So I'm just going to show you real quick. It's on the dashboard. All right, that fast. I just installed the Kubernetes dashboard, right? You saw that. It happened. It really happened. All right. Proxy. So kubectl proxy forwards the network of the node to your local machine at localhost 8001, so you can access the API locally. It's a secure communication channel. That way you don't have to expose everything to the internet just to get to the internals of your cluster, which is really, really nice. So here, and here's your dashboard. If you haven't seen the Kubernetes dashboard before, it's really nice. Here's my 5 nodes, the internal address, got some CPU and memory information. If you install Heapster with your cluster, which is a metrics gathering tool that uses cAdvisor, it will start to put graphs into your dashboard, which is pretty nice and handy. Metrics for your containers and everything. I'm not going to go through all this. If you want to use the Kubernetes dashboard, you can explore it at will. But this is just another way to validate what's going on. You can go into the actual containers and into the pods and look at their logs. There's nothing installed in default. But you can see these are all the apps that are running. These are all Kubernetes native services that are all running inside the cluster that were installed as part of KOPS. They all have purposes, so dashboard, proxy, DNS, API server, controller manager, etcd, scheduler, all this stuff got stood up by KOPS as containers within Kubernetes. So, check, another live demo piece worked. All right, let's go on to something a little harder. So, adding worker nodes. I do this when the cluster is starting to slow down or I'm really putting a lot of load on it. I will add them manually. Yes, you're asking what about auto scaling? I agree. You would use auto scaling through AWS instead of KOPS to manage your auto scaling. You can set your min and max, and I'll show you that in a second. For what KOPS is doing in the background is creating auto scaling groups for each of your auto scaling group for your nodes, and then an auto scaling group for each of your master servers. You can set those however you want by editing the cluster, which I'll show you in a second, and then sending that off. But the auto scaling is up to you. Okay, so if you want to have it scale up when the workload is high, then you're going to have to do CloudWatch alarms or CloudWatch metrics, and then set your thresholds and all that good stuff that, if any of you have done, is sometimes hard, sometimes easy, depending on how you look at it. But it's a very valuable feature. I'm just going to show you how you would manually scale up a cluster by directly editing the instance groups, which are your worker nodes, and just add a node to the cluster, which is not that bad. And then I'm going to be done super soon, Joe, I promise. Because I know you're chomping at the bit. So why do I keep putting this in, by the way? I guess I could set this in my bash from life experience, working against the wrong AWS profile multiple times and accidentally executing things in clusters I didn't mean to or AWS accounts I didn't mean to. I always just put my profile on the command line. That's me. That's a personal thing. I spelled no. I spelled. All right, I'm going to close this so you can see it a little bigger. So this is, I'm just in VI right now. Oops, there you go. This is what the state of my cluster looks like. What you can see is, like I said, I set the max size, min size. So this is an auto scaling group. You can edit this directly, save it, and then execute it against a cluster, which is what I'm going to do. It has some information, some metadata, the image I'm using, so you can see that we're running on Debbie and Jesse is the node under the covers. T2 mediums. So you can edit any of this stuff right here, just like the command line options turned into this. So editing this is the same thing as having had run it on the command line. It's just, it's changing the way the state of the cluster is. So once I change this, I save it, I still have to apply it to the cluster, and then it will take effect. So what I'm going to do is change this to 3.
Did you say versioned it also?
You know what? I'm not sure.
Or even as a part of S3. The reason I was asking is you had to roll back. Could you easily roll back?
Yeah, I'm not sure. I haven't tried versioning. If you were worried about that type of stuff, I would definitely run it with Terraform instead of like with KOPS directly, so that you have some state that you can save, like the actual Terraform manifests. Might be the way I would go about that. All right, so I edited it. Let me make sure I get the command right. Update cluster minus yes. All right, so if I didn't do minus yes, it would have told me what it was going to do before it did it. I just did minus yes, so it executed it. It said they've been applied. So what that means is it's been applied to the AWS config, but it is not necessarily rolled out across the cluster. So you still need to do, I think this is a non-up, but some of them you still need to do rolling upgrades, like upgrading the cluster. So I'm going to apply this, but I don't think it actually does anything in this instance.
resume or not? Doing AWS.
You're right. There we go. 5 demos, man. Why does anyone do this to themselves? All right, there you go. So you can see that we got scaled up already. The nodes are at 3. If we do control get nodes, and we're at 3. So, oh, nope. Yeah. Oh, it's not there yet. Saying that that's what it's going to do. Fair enough. All right. So you have to trust me that it's standing up another one. I guess we can go to the C2 dashboard and check that out easily enough. There you go. Initializing, we're getting one more. So just that easy to add a node. Not that bad, it's gonna automatically add to the cluster. There's nothing else needed to do, it's just gonna add another worker node. And then last but not least, I'm gonna show you upgrading Kubernetes to 174. We're not gonna wait for the whole thing to complete, but I'll just show you what it looks like. All right, so once again, we have the state of the cluster, and I'm going to look for 173. All right, there we go, Kubernetes version. All right, we save state, and then scan, we're just going to cheat a little bit. Update. All right, changes have been applied, and then I'm actually going to run the, this does require a rolling upgrade. What you've told it is what you want it to do, but this is something that you're going to need to roll and upgrade, especially if it's an active cluster, because it's going to stand up a new node of the new version. And when that new node is up, then it's going to take down an old node. So that way you're getting the rolling updates. You're not diminishing your cluster capacity by applying this change to the whole thing. It's going to do it incrementally one at a time and make sure that it's not making your resources fewer than what you already have.
Does it drain the node?
So not yet. So right now it's using a delay. It's actually a bug in KOPS, and they're working on, I think there's an option that you can pass it to do a drain. A drain is what tells Kubernetes a node is going down for service or going out of service. And so it will actively move applications to an active node ahead of time. Right now it doesn't. What it does is it just brings up a node and it ungracefully crushes your node. But that tells Kubernetes, hey, these applications need to go somewhere else. It's almost the same as draining it, but it's a little more forceful, I guess you could say. It's not sending a graceful shutdown to your applications. It's terminating them. Yes. Exactly. Yep. So right now that's a bug in KOPS, but you can pass command line option to have it drain, and I think it's going to become the default in the future. Let me just do my rolling upgrade just so I can say that my demo was completely successful. There you go. And so this takes a little while because it's doing them one at a time, and it's actually going to tell you in the window what it's doing. If I blow this window up, come on, don't get me right at the end. There you go. All right. So what you'll see, hopefully, and then we'll call it success, and I'll get out of Joe's way, is a 174 version node show up here at the bottom, say that it's ready and in service, and then it's going to start kill nodes out from under it, stand up a new one, take down an old one, stand up a new one, take down an old one. It's doing that. Oh, it already took down one. Well, that's not awesome. Took one out of service. Why did it do that? Do that. Let's see what we got here. I don't know why I was only reporting from. Seems like it terminated that one a little early. What's that?
Took a master out for the first one.
Yeah, it did. But it should have, I thought the delay was long enough. When I did this earlier, the delay was long enough that the 174 showed up before the 173 went away. So right now you're down a node. You shouldn't be down a node.
Is that a master?
What's that?
That's a master, right?
It did take down a master.
And then you freeze.
It is. It's not affecting cluster. It's not affecting cluster operation. But if it was to do this with a worker node, then you would essentially be down one node, and you want excess capacity, not deficient capacity, in order for all your workloads to transfer over. So if it's not ready yet, that's a problem. So maybe it's because it's a master. I don't.
Is it doing it by adjusting?
Upgrading the master, like GKE does that. GKE automatically upgrades the master. Notifies you that you will know. So that's like how.
Is it adjusting your auto-scaling group by one with that command and updating that command?
Could be. I haven't looked at exactly what it's doing in the background as far as auto scaling groups. I think it's just reinstalling, but could be wrong. Like upgrading the API server version.
By the way, one way to make the profile management easier is run a container that has in it the AWS credentials just for the profile that you want to use, and the AWS CLI and KOPS and kube control in the image.
Mm-hmm.
And then that container can only operate on the profile that you want.
The unfortunate part is I have to switch between a lot of profiles, unfortunately. And so I've had this problem where I have a lot of profiles that I'm working in. If it was just one, that would be ideal.
I mean, run the container with the profile that you want to use, so that you have
Right.
a container for each of your environments.
I could, and then, but then I would have to make sure I'm in the right container. This is, like I said, this is a total personal thing where I'm just like, think I'm in a profile and I didn't switch back. Especially when I've been managing like multiple profiles and trying to roll out big infrastructures. It's,
I've started getting in the habit, by the way, of not having SSH access at all and using the SSM agent, using the system management agent,
Yeah,
and doing things that way entirely. That way, the access is only via control.
yeah, I'm gonna look into that. 174, there it is. Success. And 173 is still there. I don't know what happened with that. I think it was still there. It just wasn't showing up for some reason. It says it's not ready. I don't know if we had a weird issue, but now I have 6 nodes. No, I'm supposed to have 6 nodes. I don't know. Anyway, 174 is rolling in. We'll just assume that that's all going to go to play. So I'm going to wrap up because I've already gone over time. Getting support if you're using KOPS. The documentation on their site is phenomenal. They have, or on their GitHub repo, in the docs section, they have like a billion readmes with way too much information. Like I said, there's a ton of options for configuring, upgrading, managing clusters. Hopefully it works for your workflow and how you work with clusters. There are a lot of options to explore. I would say play with it. Yeah. Yeah, so the monitoring tool that a lot of people use with this is Prometheus. It has Alert Manager, which can alert on Prometheus. It collects metrics from the cluster, and then Alert Manager can alert on those metrics, but you have to build that yourself. There's a lot of templates that you can template, obviously, that you can use and insert, but Prometheus works pretty seamlessly out of the box with Kubernetes. They're somewhat designed to work together because they're both cloud-native projects. So that's where I recommend with that. Then you can use Grafana on top of that to graph the metrics that you're getting out of the cluster. Yep. Yeah.
Let's actually store it in S3.
Yeah, those files that you saw, those are coming from S3. So it's like the manifest files that I was showing up there. You're just editing them essentially remotely and then saving them back up to S3.
And all the PKI keys.
PKI keys too.
Question.
Yeah.
Why does somebody install Kubernetes in AWS when you can use ECS? The vendor logging is already there in AWS.
Yeah.
So what may be use case why people be interested in?
why using Kubernetes and AWS as
Yeah.
opposed to ECS,
Yeah.
because they're very different use cases. I mean, the feature set of the two is very different. I would say, I venture to say, and this is completely opinionated, that Kubernetes is more mature than ECS in its feature set because it's based on a long time experience of container use at Google. I've personally liked the feature set out of Kubernetes better than ECS, but it's personal preference. You know, if Kubernetes is also, once again, there's no cloud lock in there, right? So Kubernetes runs the same on all of these platforms. So should you want to move platforms, you can, right? Like you can move your workload from platform to platform. There's also Kubernetes Federation, which is federating Kubernetes across cloud providers potentially, or across data centers, across regions, that type of thing. So you may run an AWS version of Kubernetes and Google Kubernetes, federate the two together so that if either one has an outage, you're completely covered. Those are the type of things that it's, you know, kind of designed to do. When I get there.
I would also mention that ECS is not clear by ECS is not clear by federal. So if you're working in the federal space,
yeah,
which a lot of us in this area are, ECS to some systems is not even an option. So you do have to pay this on top of EC2 instances, which are part of FedRAMP packets for AWS possesses, right? And then you do have to prove to the system that AI stuff about all that. So another use case would be the fact that I have to operate in a physical moderate level. Right? That could prevent me from using something like this case.
If you want to be on-prem and on SaaS,
Yes.
You're saying Federation's being worked, or is it?
Oh, no, it exists. I wouldn't say it's I think it's still in beta. But yes, there is Federation. I just haven't played with it a lot yet.
Do you have to use the use
Yep. No, you can specify your image if you want to. You can specify your own image. Now, once again, somebody asked about user data. I don't know what it's doing user data wise, and if there's something specific to those images that is already internal to them that makes them better for what KOPS is doing, but you can specify your own image. KOPS channel on Kubernetes Slack. If you're not on Kubernetes Slack and you're using Kubernetes, I suggest going there. And then there's a whole channel just dedicated to KOPS where you can get questions answered and things like that. The community is very easy to work with, can answer your questions. And then lastly, I think we've already had the questions, but if you want to find me, that's my Twitter, and then now our meetup group's Twitter, your Twitter, although it's not democratized. Sorry, just me for now. I don't trust all of you on Twitter. I don't know your Twitter proclivities. But yeah, if you have questions about any of this, definitely feel free to reach out via Twitter, email. I have my email, everything up there. Let's talk about it. So that's all I got. Do you have HDMI on that?
I do.
Okay. So you don't need my.
I do not use it.
Do you want this? Yeah. Either way.
The slide advancer?
Okay.
Yeah, let's do that. Just for fans.
All right, we're going to switch presenters real quick. If you need to refresh your beverages, now's the time. Let's see.
Does this go up and down or just left and right?
No, just left and right. It'll go each advance, just go to the next slide, even if it's going down.
Oh, very nice.
And you want to set are you sharing what you want to share now?
I just stopped sharing, so you should be able to share.
Yeah, it's up right now, so yeah. Let me look this up.
I'm going to take this off.
Have you selected the desktop you want to share, Joe?
I am going to end up sharing my whole desktop, I think, so let me flip that real quick.
Are you ready for me to select you?
1 second. Settings. Displays. Here. I'm going to stop this and then I'm going to share my whole desktop. Your entire screen share.
Okay, so we are not seeing anything.
No?
Did you select? See, I'm not seeing anything from you coming from your side.
It said that, yes. Let's see, Google Hangouts is sharing your screen. Yeah. Oh,
Like, I'll switch to the camera view. If we don't, I don't see what it is offhand, so.
no, let me, it was sharing when I did it with a specific app. So
Yeah, that's what, I was seeing it then. I was
just
seeing your slides.
application window. Share. And then later
There you
on,
go. Now I see
when
it.
I do my demo, I'll just flip windows again.
I see it now. I can switch to the camera view anytime. So you're selected and I'm seeing, let's see a Helm chart.
So I'm going to, first thing I'm going to do is hook up my power. Then I'm going
I can unplug it.
just have it. There we go. This. I'll be right back. Hey, Arca.
I got last weekend the AWS talk because you dabble with Kubernetes as well.
Yeah, I've been learning more about it. So one of those areas I've been missing. A lot of time just going around.
Sure, I haven't had a chance to go, but I do know. I just have a high level standpoint of like Google's answer to Docker.
Is the advancer working, by the way?
Yeah, seems to be. Good stuff. 2 more minutes. 2 minutes for people to notice. All right, 2-minute warning.
They call that Helm Chart.
All right, I guess I'll go ahead and get started. It's 7:50 exactly. So you've deployed your nice fancy KOPS cluster from Sam's presentation. What are you going to do with it? You're going to throw some applications in it, presumably. Well, how are you going to put those applications in? Well, one of the nice deployment systems that exists for Kubernetes is called Helm, and it's based on a very relatively simple templating system. We'll talk a little bit more about how that templating works as we go on. At one time, there was what I thought of as a competing system called KPM, Kubernetes Package Manager, that I got somewhat familiar with when I worked at CoreOS. And then when I came here, Sam said, hey, how about this Helm thing? And I said, hey, how about that KPM thing? And he's like, isn't that dead? And I went and looked at the GitHub page, and sure enough, it's been deprecated. It's no longer maintained by CoreOS. So the winner by default. So, a little bit about me. I've been doing IT and IT-related stuff since about '94. I mentioned I worked for CoreOS. Before that, I worked for Red Hat. A long time before that, I worked at Electronic Arts, among many other companies. I am currently a senior consultant at Otimo, and I've been here for about, what, 5 months? Yeah, I know. Everybody's a comedian. My blood type is caffeine positive. See, I'm a comedian too. There's all my contact info. So he mentioned Kubernetes Slack. I'm on Kubernetes Slack just about every day. I have a Twitter account as of last night. And then there's my email address there too. So normal application deployments in Kubernetes, a boring old standard deployment. You're doing stuff with kubectl create-f. We've all done that, or if you haven't done that, it's probably the first thing you will do when you set up a Kubernetes cluster. If you're a hardcore developer, you might be writing an application like the people at CoreOS write Tectonic, and Tectonic interfaces directly with the Kubernetes API server. It doesn't use kubectl, which has caused them some problems because kubectl has some dark magic in it that the API server doesn't. And they're now working on getting all that dark magic into the API server so that the two are equivalent tools. But what happens if you want to run multiple instances of an app in a cluster, or you want to upgrade an app after you've installed it and a new version comes out, or you installed it with one configuration and you want to change that? Do you have to go in and you have to edit those manifests by hand, or write your own templating system? Nobody wants to write their own templating system. There's like a billion things I would rather do personally than do that. And if you're the kind of person who says, no, I'm not going to the party, I have to write a templating application, I have some deep suspicions about you. So, you start looking at this and it's like, no, you cannot have a pony. You end up looking like this little girl here. No, you can't have a pony. Oops. So, but guess what? With templated application manifests through Helm, you can manage those applications a whole lot easier. those multiple deploys you get automatically because Helm generates what it calls a release and a release name every time you deploy what it calls a chart, an application package. So it's as though every time you installed an application on your system and a new file system path and a new set of config files, and so you can install the same application on your system with different configurations as many times as you want. Sort of like if you containerize that application. But you also get these upgrades and config changes because Helm has something that runs in the Kubernetes cluster called Tiller, which is, I'll show you what goes on with that in just a second. Tiller manages all the metadata about the various charts and releases that you've used in your cluster so far. I give you one pony, free of charge, some assembly required. You are going to have to write your own templates. We'll talk about that. So how do you get started with this thing really quickly? Well, first thing you need to do is install Helm itself. So the easiest thing to do is download the Helm binary. Just go to the latest release, download it. It's got, for Linux and OS 10. Make sure that your kubectl is set. You can either put it in the default file system location or you can use that kubectl environment variable. Make sure kubectl is in your path because Helm does use that for validating manifests, among other things. And then all you do is, we do a kubectl get nodes to make sure kubectl is good. We do a Helm init. Helm goes out and installs that Tiller manager in your Kubernetes cluster by itself. You wait for that to come up. Usually doesn't take more than a few seconds, and then you do a Helm list, and you won't get anything because you haven't deployed anything yet. But the important thing is you won't get an error either, like you would get if Tiller weren't there, or if you weren't pointed at the cluster properly or whatever. So you want that empty output as the first step to verify that everything's good. Yes?
Why Helm?
Because
If
there's...
not template, other than templating, why else do we need Helm?
One of the nice things about Helm is it has a user community, and that user community is contributing charts to Helm all the time to prepackaged applications. So what you get is the ability to take advantage of all that effort of other people instead of having to go through and write your own template for every single application you deploy.
That's why I really like the work.
Yeah.
Charts that give you to boot up.
Right. You can just go out there, and I'll actually talk a little bit later about getting things contributed. Either you can publish them in your own repo, or you can contribute them to the stable chart repo that's maintained by the Kubernetes Helm team. And I actually have a chart that I'm going to, if I have time, demo for you that's going through that contribution process right now.
Sorry, one Helm is going to create a Tiller for me, or is it for everybody for the cluster?
It's for the entire cluster.
Every cluster.
Yeah.
Another reason that I think Helm is useful is for a specific point. So I'm one day working on something. If I check out there's another one, another person can continue on because all the deployments are maintained within Tiller.
Right.
We almost a server which maintains all your deployments for your cluster.
Yeah, it makes things a lot easier if you're sharing a development cluster because everybody can deploy their own instances of applications and not have to worry too much about stomping on each other as long as the charts are well written. So this is your basic chart directory structure. There are some things that you will have to have, and they are basically just that. Really, the only thing you have to have is chart.yaml. Everything else is optional. You don't have to have a values file. If you don't, then the defaults in the chart will take over. You can have a license, you can have a README, you can have requirements, you can have subcharts, you can have templates. You don't need templates in the chart. You can have a chart that just declares that it depends on other existing charts and doesn't have any templates of its own. That's not what most charts are, but that's a kind of chart you can write. So if you want to start writing your own chart, one way is you can do Helm create and just give it a chart name. What it'll do is it'll create a dummy chart directory that by default it just says, okay, here's a chart that will deploy Nginx. So if you just do Helm create and then Helm install that directory, you'll get Nginx running in your cluster. That may or may not be what you want, but what you can then do is go into that, edit the chart.yaml, edit the templates, edit the requirements, and put your own app stuff in there. The other thing is, and this is probably the more common situation, you already have an app. You've already got a manifest written for it. A manifest is a valid template as long as it's a valid manifest, even if you don't have any template markers in it, because it's just going to render to itself. So you can throw a regular old Kubernetes manifest into the templates directory, fill out chart.yaml, and get rocking with Helm. And then you can customize that manifest with some templating substitutions later on. So the first couple of things you need to do when you're writing a chart, and you really do need to do these partly for your own use, but partly because if you actually share this chart with anybody else, it's going to make life easier for them too. Go in and fill out chart.yaml. Because for one thing, unless you have that filled out, it's not a valid chart to begin with. You have to have the name, the version, and a maintainer's name. Everything else in there is optional, but there's some things that are suggested, like the maintainer's email. You might have an app version, so like the version refers to the version of this chart, and then you can have an app version tag that tells you what version of the application you're looking at. The chart name in the name attribute has to match the name of the directory it's in. It's just a convention they use. If you do a Helm lint and those two don't match, it'll throw an error at you. Values.yaml, again, this is an optional file, but this is probably the whole reason that you're doing all this effort of going into writing this template, is that you want to be able to edit these values and do different deployments and upgrade deployments. So think about how you want to structure your values. Usually, they suggest a flat structure. You don't want a lot of nested stuff. Now, one reason for that is because it makes it a little harder to read and reason about. Another reason is because if you use a nested value, like if you have, image and then tag version, you can't use image tag version without making sure that image tag exists and image exists. Everything above that level of the hierarchy has to exist before you can use things lower in the hierarchy. And that gets annoying to write when you're writing your templates. I'll actually show you, if I have a chance, in my demo chart, some of the places that I had to do stuff like that. So rather than having image and then having sub-attributes of name and tag, you would just have image name and image tag, both as first-class attributes. Your values have to start with lowercase names. Uppercase names are reserved. And you'll see later on what they're reserved for. Use camel case rather than dashes or periods. Periods indicate levels between hierarchies in values in YAML, and dashes aren't valid YAML keys. So, yeah.
Can you do valid YAML, let's say you can do quotes around your key with a dash in the middle?
You can do that. The other thing you can do is in your templates, if you do have something with a dash in it, which I do, you can use the index function and say index the values hierarchy and then the name of the key that has a dash in it. But that's super annoying to do, and there are places where it doesn't even really work. Yeah. You can do it, but you have to escape it properly. Unescaped YAML keys with dashes in them are not valid key names. The other thing you want to do in values.yaml is add a comment documenting each value, and that comment should start with the name of the value. The whole reason for that is so that somebody can just go grepping through your values.yaml and get the name of the value that you have preset and also what it means. Readme.md, it's for humans, so it's not written in YAML, although it was suggested to me when I submitted my chart, hey, you should throw your values into there as a markdown table instead of just a list. So make it look nice. Notes.txt, this one's fun. This is a template, so it goes in the templates directory, and it's rendered and displayed after every release is installed. And so what the idea of notes.txt is you just installed this application. Now here's what you do to access it, or here's what this application will do for you. So what you want to put in there is how to use the app, how to access the service, how to run the command or whatever it is that app is doing, and be specific. When I submitted mine, the guy said, hey, why don't you, instead of just putting a list and saying if you used a load balancer service, or if you used a cluster IP service, or if you used a node port service, just have notes.txt render that, and then give them the commands they need to run instead of making them read a list and pick what's right off the list, because all the info you need to render that is already there. So you can tell the user rather than making the user decide. So deciding what to template. I mean, you can go nuts. You could sit there and template things all day, but the thing is, at some point you're going to be writing templates for things that nobody cares about, right? Like probably nobody cares the name of a container. Maybe somebody does, but most people I don't think care about the names of the containers that are running in their pods most of the time. So, you know, we'll talk a little bit about what to template and what not to template later. This is the basic syntax of it. You have double curly braces around every substitution. And so what it's doing when you do that, when you say .values .something, it's taking that key, if it exists, out of your values.yaml file, or off the command line if that's where you supplied it. So if you say foo pizza, and then you have I like double curly braces, values.foo, double curly close brace, you get I like pizza. Pretty simple. Then you have, remember I told you that your values have to start with a lowercase letter. This is why. Because capital release and capital chart are reserved. Basically anything that starts with a capital letter is considered to be reserved for Helm built-in values. So some of the built-in values you have are like release.name, chart.name, things like that, chart.version, release.namespace. These are things that Helm generates for you as part of your release process. You don't template these things yourself. You have various functions you can use in your templating. So Go and Sprig templates functions can be used in here, but not all of them. And honestly, I haven't found a good comprehensive list of which ones. And it seems like if there's one that you want to use and they don't have it included yet, they're pretty responsive to say, oh yeah, we'll go ahead and throw that in. I don't know, why they're doing that process instead of just including everything. Maybe there are some conflicts there. I'm not a developer. I don't really know that part of it. You can include other named templates. So you can have a name template that generates like a date stamp or generates a unique name or some other kind of unique string. And you can give that template a name and then you can refer to it in your other templates. You have conditionals, you have loops. I mean, it's almost a programming language. Not quite. It's not Turing complete, I don't think, but it gets pretty complex. Some of the more important best practices. Indent with 2 spaces. If you're a tab indenter, too bad. Chomp unnecessary white space. Remember those double braces indicate substitutions. If you have a dash, you chomp white space in that direction. So a double left brace with a dash means chomp white space to the left, all the way up to non-white space. Same thing with the right. Dash double close brace means chomp it to the right, all the way up to the next non-white space. If you have repeated blocks of things, go ahead and abstract them out as a name template, and then just include them by name, by reference. That's what I did with the Weave Scope chart that I wrote, which is the demo chart that I'll show you later. They had a specific block of annotations they put into every single resource. And I said, that's just making it longer. I have a templating system. I can abstract that out and just make that a name template and refer to it when I need it. The other thing is charts should do something reasonable even if the user supplies no values at all. So even if you supply default values in an included values.yaml, you should try to make your chart do something reasonable even if that's not there. The user deleted it by accident, or they said, I'm playing around, I want to see what the default values for this are when nothing's there, or whatever. Now, there may be cases where you can't do that, in which case you can mark that value as required and say, if you don't supply this, you don't get to install this chart, because it makes no sense to install this chart unless you supply this value. Like, if you have a chart that's going to interface with some external service with an API key, you make that API key required. The user has to supply it. Otherwise, there's no point in running whatever it is that you're providing. But for things that can take a default, you can use the default function. If you notice, there's kind of like a pipe syntax there. We're just calling a value, and then we're piping it to this default function. And default says, if that value doesn't exist, I substitute it with whatever this default is. Something, some string, could be another value. Template snippets, I kind of referred to these by reference a second ago. You can have things that don't render to an entire YAML manifest, like normally would be expected of a template. They just render to a string or a block of text or something like that. And you can put those in, instead of a .yaml file, a .tpl file. And then they're not expected to render to valid YAML. You'll see a couple of these in just about every chart. There'll be a name template and a full name template in _helpers.tpl. You can add your own. Like I said, I put the standard Helm labels and the annotations from Weave Scope into that helpers.tpl as well. There are some standard labels that Helm wants you to apply to all of your resources. Heritage, release, chart, and app, fairly obvious. Chart is, in this case, the chart name with the chart version included. Release is the name of the release, which it auto-generates, unless you provide it with one. And then heritage, right now, is always going to be tilde. Labels versus annotations. Now, this is not so much a Helm-specific thing. This is really just a good practice thing generally. Use the labels that you need. Labels are for selected things. If there's not ever going to be a need to select something by the label you're setting, don't make it a label. Make it an annotation. This was something that got kicked back on my chart when I submitted it. He said, you've got labels there that you aren't using to select anything. I was like, oh yeah, okay.
Question.
Yeah.
So where are annotations used?
Annotations are just applied to resources. They aren't used for querying things. I think you can query by them if you want to.
Actually, they are used by other programs, other applications. Like example, Prometheus looks to create annotations. If you want to scrape something of your chart or your service, it looks at annotations and tables and tables.
Well, the other thing too, the most common thing I think people see annotations for previously was when you wanted to mark a node as a master so that it wouldn't run workloads. Before they had the taints and tolerations in Kubernetes, you would give it a specific annotation, and Kubernetes would look at it and go, okay, no workloads on that.
You only use by systems.
Yeah, but labels get used by other applications for things like, labels get used by resources to indicate, okay, this is a sub-resource that I manage. Like deployments use pod labels to figure out which pods they are responsible for, and so on. Which then rolls into this, which is because we're setting all these standard labels, you want to set explicit selectors for daemon sets and deployment sets of match labels. For service, it's just a selector. Because if you don't specify explicitly, the entire set of labels in that daemon set will be used as the selector, and that will break things like upgrading to new versions. So that's not what you want to do. This is just a little oddity, but it's something that I decided is actually fairly important to call out. One of the standard items that they will have you do is set the image pull policy to be blank. And that's because you don't want to surprise the user with the first time their pod restarts, they get upgraded to a new version of the application without warning, because that may break things for them. So they're kind of enforcing as a best practice for Helm that you obey the principle of least astonishment and not force an upgrade on your user without them saying, yeah, I want to auto upgrade. I like to live dangerously. Resource limits and requests. A little bit ago, I said they prefer that you use flat value namespaces. This is kind of the exception. Everybody just specifies this in a block of hierarchical YAML, just like people do in Kubernetes manifests, and that's fine. That's just the exception to the previous convention that's become a convention of its own. So you'll see resources, indented, limits, then your limits, then indented under that, requests, and so on. And they have to be templated in. That's one of the standard practices, because you want users to be able to say, all right, I want to deploy this Helm chart with limits applied or with requests applied without having to go in and edit your templates to do it. Testing your chart. First thing is, if you think you've got your chart into a good state, you can just run Helm lint. So you go into the directory where your chart is, you do Helm lint dot. It'll do a basic syntax check, and maybe it'll throw an error, or maybe it'll say, one chart linted, no errors. You can use strict. If the first check passes, you use strict for a slightly stricter pass. That will not catch everything, though. For example, that won't catch things where you have a problem where one of the resources you would deploy is named the same as a resource already in your cluster, because this is all just happening locally. This is not going out and trying to actually do like a test deployment on Kubernetes. It's just a syntax check. This is getting a little bit more involved. If you do a dry run, then it's still not trying to deploy it, but what it will do is it will go ahead and render the chart and try to validate that chart through kubectl. So you'll pick up some more errors. If you do the debug flag, it will actually give you on the command line, in your terminal window, the rendered YAML that it would put into the cluster. So you'll see a lot of the time when people go into Slack and they say, I'm having a problem with my chart, I got an error. The first thing they'll be asked is, well, what does debug dry run tell you? And that does validate those manifests with kubectl. As a test, go ahead and install it, see if it works. If it works, then you've got presumably a good chart. If it doesn't work, you've got some work left to do. So I've mentioned little bits and pieces of this. So this is the actual Weave Scope chart process that I went through. I don't know if anybody here is familiar with the Weave Scope application. Basically, it is a cluster visualizer and monitoring system. And if my demo goes well, then you'll actually see it's really slick. It actually puts up a nice little visualization in your web browser, and you can zoom in on it and click things to get more details on them and stuff like that. So when I started here, Sam said, hey, how about that Helm thing? And we had that conversation. Then he said, so one of the things that I want is a Weave Scope chart. There was an existing chart for the old version of Helm, like what's called Helm Classic. And it had never been updated. So it was like Weave Scope 030 was that chart. He said, why don't we go ahead and write that? And I said, sure, it'll be a quick learning experience. Ha 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 ha. Little did I know. But it actually turned out to be a good learning experience because it dug me down into some of the really darker nooks and crannies of writing a chart. So the first thing is to go get the initial manifest. Well, Weaveworks provides that right on the website. You go in, you tell them, what Kubernetes version you're using as an argument to that long URL there, and it spits back a manifest at you. And that manifest is a list array of resources in a single file. Because of course it is, because how else would they give it to you at a web request if it wasn't a single file? So the first thing was I was doing stuff with it, and I went into charts on Kubernetes Slack, and I think I went into Helm users. I wasn't in charts yet. Went into Helm users, and I was having some kind of issue, and I was talking to people there. My old coworker, Chance Cebulski, said, well, when I have a chart like that, what I like to do is break it up into child charts. And I was like, oh, that's a thing you can do. Sure enough, that's a thing you can do. So I broke it up. I said, well, then naturally, the agent is one subchart, and the front end is another subchart. So the big win there was now that made it very easy for me to say, in the top level chart, deploy one component or the other. The other thing is either one of those subcharts could be pulled out and used all by itself as an independent chart. The other thing, and this was something that came up when I submitted my pull request to get this chart submitted, was break your charts up so that every resource is its own template. This just makes things easier to read. And I remember thinking, oh, geez, I've got this long list, and it's a real pain to scroll and slash search back and forth through this file. It would be nice if I could actually look at the whole thing all on one screen in my terminal window. Well, if you break it up, that's a lot easier. Things that I chose to template besides those basics that we talked about, the resources and the image pull policy and all that. Service and service account names, because some organizations have very strict policies about what user accounts can be named or what host names can be. And since a service ends up internally as a host name and a service account internally ends up as essentially a user, it's nice for those organizations to be able to just specify that up front. Service type and port. This was something that to specify this in the original source manifest, you actually had to go in and just edit the service. object and say, you're a load balancer now, or you're a cluster IP now, or you're a node port now. Said, well, let's just template that. Because not everybody has control over their firewall. So if I didn't template that, again, it makes it a pain for somebody to say, well, our firewall won't let the node port range through, so I have to go in and edit that node port service and turn it into a cluster IP, and then forward that. Docker bridge interface, you never know what a network interface is giving you. So that was an obvious thing to template. And the container port, I went ahead and did because, yeah, the odds of it changing from 4040 are pretty slim, but you never know. This was another one that was interesting, and this one actually got me into some trouble later on when I was templating the notes. There are basically 3 different ways that Scope's agent can access its front end. It can report to Weave Cloud out on the internet. It can report to an existing Scope front end somewhere at some host and port, or it can report within the Kubernetes cluster to Scope front end running as a Kubernetes resource. So I said, and this was a real pain because what they had done was they put all 3 options into the manifest, and then they said, comment out the one you want to use. And I was like, I don't like that. So I'm going to make the template do that for me. Things I didn't template. I did not template any of the RBAC related resources. I didn't template the cluster role names, the cluster role binding names, none of that. Why? Because I don't want people just deploying this application willy-nilly in there and binding a lot of stuff as a super user and not knowing that they have all this stuff bound as a super user. Just keep it to one instance, or go in and edit the manifest. If somebody wants to template that from themselves, that's fine. I don't want to make it easy for a user to step in a hole and have a lot of super user bound stuff running in their cluster. Then there was stuff that people probably don't care about. Like I said, container names, does anybody care? Has anybody ever cared? Not unless you're actually writing the manifest from scratch, and then you probably go, all right, we got to pick a name. Just give it a name and we'll be done with it. So writing this, it sounds simple. I've made it sound simpler than it was, but life is complicated. One of the things I ran into was writing notes.txt. I needed to be able to refer to values from both child charts. There's no easy way to import, well, excuse me, I'll get to that later. Values needed to match between the child charts, because if the agent is trying to report to a service that's named differently from the service that's actually in front of the front end, that's not going to work. So I said, well, what am I going to do with this? There's no easy way to import a child chart's values into another child chart to make sure that that can be enforced. So I had to make those global. It makes it a little bit more of a pain to use those child charts independently, but it makes the parent chart a lot easier to deal with. This is where the real trouble came. The child chart names had dashes in them. We talked about that earlier. YAML doesn't like dashes in key names. You have to quote it. You have to escape it. It's just a big pain in the butt. So fortunately, Helm has this alias function. You can alias a child chart or in the requirements.md file and say, hey, in this parent chart, you have a different name. So I aliased Weave Scope agent just to agent. Weave Scope front end got aliased just to front end. I rewrote a couple of value references and I was done with that. So I did an end run around that problem. The other one that was a pain with notes.txt was getting the conditionals right, because there were so many different ways you could end up with deploying these 2 charts in combination with each other that it was a little bit complex to actually sit down and reason through the decision tree of what commands to output at the end to say, oh, you ran it as a cluster IP service and you did supply a name, therefore this. You ran it as a cluster IP service and you did not supply a name, therefore this other thing. So I ended up with this big ugly set of branching if, else stuff, but it works. If it's ugly but it works, I'll take it. Where you can get help, and I know this because I went here just about every day while I was writing this thing. The Helm docs. Kubernetes Helm and Kubernetes charts both have lots of great docs on GitHub. There is also a project site off of GitHub at helm.sh. There is this specifically that I wanted to call out because I was all over this thing, the Chart Template Developers Guide. It's in the Kubernetes Helm project, and it's in the docs directory. And it's this Chart Template Guide directory. So I would almost go look at that first before you go look at the other docs, but definitely know that the other docs are there. This is the other thing you should look at in pretty much a lot of detail. This is the Kubernetes chart best practices. Let's see, this one was in Kubernetes Helm. This one's also in Kubernetes Helm. Basically, 2/3 of this talk is stolen straight from that file. So if you go read that file and you go, oh, yeah, that was what that guy was talking about. That's what you should be thinking. Kubernetes Slack, there's charts. If you're writing a chart and you're having problems getting it to render properly, that's for charts. Helm users, if you try to do a Helm upgrade of Helm itself, it fails, that's where you go for that. Helm Dev, I only mentioned just because it's there. It is not a user help channel. It's for the developers to coordinate stuff. If you were to become a Helm developer, go ahead, knock yourself out. There may even be occasions where somebody in Helm users will say, hey, so-and-so is in Helm Dev, go ask him there. Publishing. Like I said before, you can create your own Helm repository. How do you do it? You set up static HTTP hosting. That's it. That's all you got to do on the server side. Just have a bucket you can stick it in. Packaging your chart. Once you've got it written, you say Helm package, the directory name. You download index.yaml from your repository. If you're just starting one, it'll be empty. You don't have any charts there yet. Then you run this. It's actually hard to see because it scrolls over here, but you run this Helm repo index merge command, and it will create a new index with the chart that you just packaged up, written into that index. You upload the chart tarball and the index to your charts directory in your static web host, and you're done. Now you can add that repository to your local Helm client, and you'll use it for charts. The other thing you can do is submit your chart upstream. There's a stable repo of community-submitted charts that's maintained by the Kubernetes Helm Chart team, and they welcome pull requests. There's contribution guidelines, of course, but it basically boils down to, do you meet the technical requirements? Does it run? Do all your pods come up? Do your services all end up with endpoints? Does it function in a very basic manner? And then there's documentation requirements. Did you actually go in and write sufficient documentation in readme.md? You probably didn't. I didn't. They asked me to write a bunch more. To do that, if you want to submit upstream, you're going to need a GitHub account. You're going to need a Cloud Native Computing Foundation account, which usually means Linux Foundation. And you got to sign the contributor license agreement, just like you would have to do for any number of other projects. The important thing here is make sure that your email on both those accounts matches. And when you configure your local instance of Git, make sure your email matches there as well. Because if those three don't match, and that happened to me, Git won't recognize that your commits belong to your user. The bot won't recognize that you've actually signed the contributor license agreement because you used a different email over there than you did on GitHub. It's a real pain in the butt. What I ended up doing after the first submission was I fixed it all, and then I just deleted that PR and resubmitted because it was such a pain to fix it any other way. It was easier just to blow it away and start over. Anybody here not forked a project on GitHub to make contributions? Okay, so we've pretty much all done that. I'm not going to belabor the point, but it's a pretty standard workflow. Fork it, clone it, branch it, add your chart in the branch, commit and push. Then once you commit and push, if you did everything right, you can go to the parent project, Kubernetes charts, and do your compare and pull request. The bots will come in and tag your PR, whether you've signed the contributor license agreement or not is the first thing that they're going to tag. So you want to make sure that all your emails match so that they can tag it yes, and then you can get a review. Nobody's going to review it until you sign the CLA. When they do review it, they may request changes. Just commit and push again. Anybody have questions? That QR code and that URL at the bottom go to a web-hosted copy of these slides. If anybody wants to grab it, yeah?
Other than the linting, are you using any or are aware of any tools to use sort of additional integration testing for your charts?
I mean, you can use whatever other integration tools you want once you deploy it, but as far as pre-deployment, not that I'm aware of. Sam might know better.
There is
you go.
post-deployment. Post-deployment, there's something called KOPS. You can write chart by chart as and post-deploy, pre-deploy.
Yeah.
So I'm still trying to grasp the concept of what Helm does. I'm well aware of what manifests do, but I haven't really gotten into like packaging my manifests approach. So is Helm really just parameterized manifests? Or?
That's the meat of it. The other thing that it does, besides just allowing you to parameterize manifests, is it manages them. It manages the deployments for you, which I'll show you a little piece of that in the demo. Do we have time? What time is it? 8:29? Yeah, we probably have time. I'll show you a little piece of that in the demo in just a minute. But basically, Helm makes it very, very easy if, for example, a new version of an application that you have a chart for just came out. You don't have to go edit a manifest or anything. You just go Helm upgrade, set the new image tag, and give it the release that's already running and while you're off and running, which I will show you momentarily. So let me flip over to my command line windows.
One of the things that I found pretty helpful was how to inspect, because anytime I want a new chart, I want to know what was in that and the values and things like that I had passed. So the Helm inspect command has to be pretty handy.
Let's see, can I do my entire screen here? I don't think it'll let me do my entire screen. All right, let's do. Oh, that's weird. I can't share my terminal windows. Okay, well, I'm going to put it on my entire screen, and I don't know what we'll end up with here. But in any case, let me minimize that. Okay, so I have two terminal windows. One that I'm just going to be using for port forwarding, and the other one I'm going to be using for the actual deployment. So, first thing is, I have a chart in this directory. And actually, let me pump up my terminal size here. Oops, what is it? Oh, set title view, zoom in, control plus. Oh, right. Okay, so. All right, so we can all read that, more or less. Okay, so I'm in this Weave scope directory. This is where my chart is. So I can Helm install that. I have everything set up so that it will generate this as a node port service for access. And this is what I was talking about. My template looks at the values and says, oh, you deployed it as a node port. Therefore, to figure out where to go to access that thing, you need to run these commands. So I can just copy and paste. And it says, hey, one of these two is probably what you want. Now, actually, this is not running somewhere that I can access it directly. It's running in that little black box in the corner of my desk. So what I am going to do, though, is over here, I'm just going to port forward 8080 to 30872. And then over here, I can go to localhost 8080. And look what I have. So I have all this stuff running. This is actually, this front end here, this is an earlier deployment that I did without Helm of the standard Kubernetes guest book. I can click on this. I mean, this is basically just Weave Scope, but that's the point. In like 2 seconds, I deployed Weave Scope, and not only did I deploy it, it actually told me, without me having to go ask it anything, where to go to access it. So I didn't have to go in and say, hey, kubectl describes service, blah, blah, to find out what the node port was. It just told me because I wrote my template that way. So But notice something down here. Update available, 163. What am I running? I think I'm running 162. Yeah, version 162. So 163 just came out, like probably in the last couple days. Now, what happens if I Helm install, actually not Helm install, I'm going to cheat. I'm just going to go back in my history to where I did it previously. My release name is Exiled Deer. So I go, there we go. My release name is Exiled Deer. I say update Exiled Deer with this new value for the image tag. I want to upgrade my application to 163. And it says Exiled Deer has been upgraded. And then it tells me some quick status. Now, looking at this, actually some stuff bounced around there. If I refresh, now we see I'm running version 163. And it was that easy and that quick because I wrote the template to be able to do that. I like to just play around with this. This is great for demos because you can just click on things and do stuff and zoom in and zoom out. You can go like this, you can go like that. You can click on the internet. How many times do you get to click on the internet? But I mean, you can do that with any value. I could actually change the container name. If we've decided, hey, it's not going to be called Weave Scope anymore. It's going to be called Weave Lens. I have an image name template value. So the next time I go in, I can say, hey, Helm upgrade -- image tag image name Weave Lens. That's as easy as it is. Anybody got any other questions?
Not about Helm, but is this independent of what we've started as an overlay?
It is an overlay network, and this actually does have the capability to interface directly with that overlay network. In fact, if I were to go in and look at the agent pods, they would be spewing out informational messages about, hey, I tried to access the Weave network agent, and I can't because it's not there, because I'm not using Weave network in this cluster. But yeah, that's the thing most people are familiar with, but they have all these other management tools that kind of go along with that.
Consistent cloud is similar.
Yeah, and we actually, when I worked at CoreOS, we had a lot of people that were good friends with the Sysdig people. So we did like joint meetups with them. They came to our events. We went to their events. One of the interesting things is, I don't know if any of you have seen the cloud native computing landscape diagram that just keeps getting bigger and bigger and bigger. It's this amazing diagram that the Cloud Native Computing Foundation, if I can find it real quick here, landscape.
Sorry, I guess my fundamental first question was, this does not rely on being run any other week.
No, it doesn't.
Okay.
This is just interrogating the API server. But if you are running other Weave products, it will interface with them if you set it up to do so. So, yeah, so here's the cloud native landscape, and I think Weave is actually on there somewhere, but this thing is ginormous now. I remember when it started, when I first saw it, it was about a quarter that size. All those logos were a lot bigger.
I think that's just a map of the Bay Area.
Yeah, it is. It's funny because if you look at a map of San Francisco and you put pins in where all these companies are, they're like all down in the Mission, or they're all up by Fisherman's Wharf. They're all, and you know, there's different projects like Claire's CoreOS. Somewhere over here, Container Linux is CoreOS. Where's Weave? Weave is in networking. So Weave is, where did it go? CNCF, provisioning. I don't know. It's on here somewhere. That's the thing. It's getting so big, it's hard to find anything on the cloud native landscape anymore. It fails as a map now. It's too big. Yeah.
Do you think that, like, so a lot of the typical applications that are run in like system containers, like group systems, do you think those will show up in Helm at some point as packages? Or am I not really thinking of it?
Well, okay, so there's kind of a chicken and egg problem there, right? Because Helm basically needs the basic infrastructure to be there prior to doing anything. Having said that, if you've ever deployed a cluster with kubeadm, it doesn't deploy an overlay network until you deploy one into the cluster. So I think it's conceivable that that could be packaged as a Helm chart. So you could say, I don't know, so that's the thing, I don't know if you could get Tiller to run without some kind of overlay network running first.
Why does Tiller need an overlay network?
It's how like if you're running by network, how will it communicate with which where container is under which node does not have any knowledge. So it doesn't need a way to work. That's at least.
Because one of the things that Helm is doing is it's looking at where things are running. So, I mean, it might work. It's certainly worth a try. I mean, if you want to go set up a cluster with KubeADM, or now that you've mentioned it, I might do that. I actually have a talk that I'm working on. I sent in the abstract. I don't know if I'll get to deliver to KubeCon, but I sent the abstract in, and one of the things that I'm going to be, if they approve it, one of the things that I'll be talking about is, you know, basic troubleshooting in your Kubernetes cluster. And one of the things that I'd be talking about troubleshooting is, oh, shoot, I forgot to deploy an overlay network. How do you recognize that? How do you fix that? You fix it by deploying one. That's pretty much how you fix that. Anybody else?
I was wondering, versus operators. I mean, precisely the previous question, I was thinking that some of those things, we have the Kubernetes operator, right? Which is one of the systems and things and applications. So maybe that's closer to.
Yeah, and I think I have seen Helm charts for things like the etcd operator. So anything you can deploy using a manifest, you should be able to write a Helm chart for. It's just, you know, when you talk about deploying the kube system components, you know, first of all, most install systems are going to want to deploy them in an opinionated way. If you try to do something like Tectonic, it's going to deploy all that stuff for you. In fact, it's going to deploy things like Prometheus for you too. KubeADM likes those things to be deployed in a specific way. Bootcube likes them deployed in a specific way. KOPS likes to deploy them in a specific way. KOPS by default doesn't even activate RBAC. So, you know, like I tried to deploy this Helm chart on a KOPS cluster and it failed because one of the things it tries to deploy is a cluster role and a cluster role binding. And with no RBAC, those don't even work. So, you know, yeah, that's something that for like version 1.1, I might actually template that in and say, if your cluster doesn't run RBAC, then set RBAC false and it won't try to do those. Yeah.
Question. If I have to upgrade an application, let's say 80% of the time, it's time to upgrade that. It's one question. Can I split upgrade?
Split it? You mean like upgrade some of the pods and not other pods or something? Not within a release, I don't think, because what it's going to be doing is editing things like deployment manifests. But what you could do is you could have two instances of that application that are separate releases, and then you could just upgrade one. And then on top of that, you could have, for example, your own service that fronts pods in both of those releases. That's not something.
That is kind of possible. Deployment, you would have an option to force it. Once I have 5 instances running, I can say, you know what, I want to roll out 2 of them and see how they behave before I roll out all the way. That's what deployment Kubernetes deployment, that's what we use. Yeah, they've worked on that. So there's like an initial delay. But I mean, as far as actually telling it that you intend, say 2 out of 5 to get upgraded, I don't know that deployments are intended to allow that. But yeah, they've been putting things in around delays to say, okay, we just want to throw a couple in there and see if it actually works. Kind of like a. There's a parameter that you can specify, say how many pods I want to go about doing it, and after you get process, and then you get an upgrade. You can do that. That was one of the demos that Tim Harvey did when deployment specifically came on doing from replication controls to deployment. That was significantly different between replication controls.
Yeah, the other thing that they do differently with deployments is that you can specify how many pods at a time get upgraded to. Whereas a rolling upgrade used to just be 1 at a time. It was like 1 in, 1 out. Now you can do 2 in, 2 out, or however you want to do it. You can set the pace. So that's the other thing you could do is you could say, okay, I want to set up this deployment so that the pace between pod upgrades is like 3 hours. I mean, there are ways that you can fudge it, like he's saying, there may be a way that you can just specify a set number. Yeah.
2 questions. Did your Helm chart for WeaveScope get accepted and committed to master on this?
It's going through the process. There's actually another commit that I need to throw in because I realized earlier today that I had a small bug that things weren't quoted that should have been. And there's another thing too. I intended to submit it with a blank values file, and I accidentally had some values uncommented from testing. So I'm going to throw another commit in there.
So follow-up question.
Yeah.
Where are the images hosted? Are those your Docker hubs?
No, that's actually, the image is just the WeaveScope image that they host wherever.
So you're just pulling from them directly. You're not building your own.
No, I'm not building my own image. You could.
Do a lot of Helm charts include random images from places? Like somebody's
Well, usually what you're doing with a Helm chart is you're deploying an application. So it's not so much that it's random images, but for example, if you're doing a Helm chart to deploy, I'm just trying to think of something that's hosted on Quay.io. Like if you're doing a Helm chart to deploy etcd, that's going to be pulled from Quay.io because that's where etcd is hosted. That's the official repo for etcd. I mean, it's not specified anywhere, but as a best practice, unless there's a reason not to, I think you would be expected to use the official container wherever that official container is hosted. They do have, when you do your chart.yaml, one of the things in there that you can put in is a source tag for the GitHub source, and then like I forget what the tag name is, but it's also to point to the project homepage. So in this case, I have, pointers to the WeaveScope website and also the GitHub WeaveScope project.
I'm just trying to ascertain the level of trust that's given to a Helm chart. Oh, yay, who mentioned your cluster? Where did it come from? Because if you're not looking under the covers where the image is sourced from a repo, but the pushed image in Docker Hub that was quote from that repo could have been modified in transit before that.
Well, one of the things too, that's one of the reasons that it's nice to template out the image listed, because then somebody could go, well, we have our own local version of WeaveScope that we've customized for our deployment. We want to use that. Well, then it's as easy as just going, okay, image equals our repo / WeaveScope. But I mean, as far as level of trust, that's actually one of the reasons that the Rocket container runtime exists, because there really was no trust originally with Docker Hub, because you could do things like there were insecure registries and things could get modified in transit. And so the core OS people looked at it and went, wouldn't it be nice if container images were signed and everything was auto-discovered over HTTPS so that everything was protected in flight, and you didn't have to worry about bad actors modifying your container image. So that's why they wrote Rocket. Now, the stuff that they wrote for Rocket originally is now included in the OCI spec for container images. So the original Rocket container image format called ACI is kind of fading away, but look for that to become a thing, more so than it is today. Because yeah, you're right, today everybody just goes Docker run whatever, and wherever it comes from, that's great. Anybody else? I see it's starting to empty out. All right, I think that's, yeah. All right. Where is Weave on this thing? I know they're here.